All right, so let's say we want to find the volume of the solid that's generated by rotating the region bound by y is equal to x squared and x is equal to 0 around the y-axis. And then, of course, let's also have it be bound by y is equal to 4 so that there's some kind of cross-section at the, or cap at the top here. And when you rotate that around the y-axis, you're going to get a shape that looks kind of like this. Okay, and what we want to do is find the volume of this shape. So if you cut a cross-section out of here, and I'm not going to do it because I tried earlier and failed, but if you cut a cross-section, you're going to be looking at a circular disc that looks kind of like this. And that's what this cross-section represents. Now the thing to keep in mind is that the radius of this disc is in terms of y. So we are going to have to solve this equation for x to get it in terms of y. So we'd have the square root of y is equal to x. Well, each of these discs has a surface area, face area, I guess I should say, of pi r squared. And we're going to multiply that by the thickness of each of these discs. So you can kind of see from earlier, I tried cutting a disc and it didn't work well, but this is the kind of the thickness of that cross section. So we'd have pi r squared, where r is actually the square root of y, multiplied by delta y, or the thickness of the cross cut. So you throw it into the integration formula, you got the area from 0 to 4, because that's where it's bound above here, of pi r squared dy, but r is, of course, the square root of y. You throw that in, you integrate, that's going to be the volume of the solid.